Hello everyone. So let's start today's class. So I give a quick recap of what we did on the last one. So in the last class, we did this screener query controller. We built this where we fetched an index from Pinecone, and then from that index we fetched our documents. Like we made a query REST controller endpoint to which like whenever we write any query, it will give me a screener queries as my output. Right. So today what we will do is we will try to index from our from this from our IntelliJ, not from Pinecone, like existing index. We won't use it. We will build our own index, right? A vector index using our Spring AI. So here for this, let me quickly go to the POM file first. So what we need is we will need this dependency, which is basically Spring AI vector store. So we are using this. In the last class, we were using Pinecone store because we were directly communicating with Pinecone, right? So now we want to use a vector store or local vector store. Okay. So now one thing is because we were using in our last class, we were using Pinecone. So like we had our configuration as here. So now because will be introducing another vector store, so we need to have our like bin names, right? So that we can properly identify, that we can initialize which vector store to use when we can refer to that. So that's why we are naming this bin. Our last project that we did, the changes would be then naming this bin as the Pinecone store, so that whenever like if I go and use this qualifier, so I know like the vector store that I'm referring to is the Pinecone vector store, right? Because now we'll be introducing our local vector store. So here, so this is our new vector store, right? So this is what we are trying to do. We will be indexing some documents into our local in-memory vector store. So here I name it as a local store. What we are doing is this embedding model. This is basically the same that we used in our embedding model. So this is the embedding model that we're using. It's same as previous one. And then we are doing a simple vector store and building it with this embedding model. Right? So now we have, if we use the qualifier as local store, we will have our simple vector store ready. So let's go now to the controller. So here what we are trying to do is, for this class, what we will do is we'll just create some dummy documents, right? And those documents we will index, and then we'll try to query those documents, right? So here, if you see, so I'm just building some, one endpoint, which is like the docs endpoint. Here I'm using this local store that we have already mentioned. We have created a bin for. Now here, if you see, this is the, like what I'm doing in movie list, creating a list of documents. So this document, if you see, it's a org Spring Framework AI document. So this is the document we want to have it, right? So anytime we are like, even if we create some our own Polio class, if we have to have a document that we need to index, or whenever we are fetching it, it will come in this format, right? So Spring Framework AI document. So here we are creating a list, bunch of documents. So one of them, like we're just giving some names of the film, so title, year of release, and genre, right? And then basically just a small summary of it. So some documents we're just a couple of the documents we have used. So I'm just mentioning here like the drama genre, action genre, sci-fi, animation, sci-fi, crime, action. These are all the genres we use. So this is my movie list. Now next is what I need to do is, and we want to index these documents into our vectors. So it is pretty straightforward. What we will do is, I just use a get mapping. We can also do something like on starting our server itself, we can index this document, right? So in this case, what I have to do is, if I hit this endpoint, then only we will index this document. So here vector store dot add, and then we are calling this movie list, right? So we are adding all this movie list into our vector store. So this is basically just the default one. We are not doing any other configuration, any other it's basically the default one. No other, we'll go deep into more like how can we do more configuration over on top of it. Like if we can add, if you want to add some like junking and all, how do we do all those things? We'll cover it in another class. So next is after we have indexed this document, we want to get like the main thing is we want to get some relevant documents. So this is basically what we do when we search, right? When we do a vector search. So here the endpoint is /movies. So what I'm doing is I will be passing the genre from the endpoint, right? The user would be passing the genre, and from this genre we will from our vector store we'll do a similarity search, right? Similarity search. So for this we need to build a search request with the query would be my genre, right? So here also we can do like we can build our own query, something like a prompt query, right? But for now I'm just keeping it as a simple one word genre, right? And we are fetching top three documents from our vector store, and we are making a build. And then this is because we're doing this similarity search, so it will give me all these results, right? And we are fetching this list of documents, and we will get on this, right? So this is like just head start to understand it. So let's see how it works. So now I haven't done the indexing yet, right? So I've just started the server. So if I go, so what I'm doing is I'm calling these movies with a genre cartoon, right? So now if I do, it should give me a empty, right? Because we have not done any indexing. So let's go and do some. Okay, these are the previous one. Let's do what was our call? It is /index, right? So let's do it. I kept it as get. Ideally, you should do a post call over there because we are making some changes. Let's see now. So here you can see we are making some embedding calls, right? For all these documents, we are making embedding calls, so it will get indexed, right? Yeah, we got a response is okay, so it should be indexed now. We're returning this response. Now let's go back to our cartoon movie cell. So now let's see how it works. See here. Okay, why trying to return this is clownfish. So if it is a genre, it's an animation genre. Again, the second one, it's an animation genre. Young Lion. So we have given cartoon, so it's like the matching similarity one is animation is the closest one, right? So now if I see here, if you see the genre is action, and if you see the text, it's Batman faces Joker. So it identifies like Batman. We know Batman is also a cartoon or you can say an animation. So the nearest because we gave took top three, right? So if the nearest one it fetched is this one other than this two. So if you see the score, it is 3.34, 0.345, 0.347, and this is 0.3, right? So it's of least third priority, right? And these two are the animations, or these are the top priority. So this is basically it's working as expected, right? So this is the power. So if I go a bit just to give you a basic understanding. So here what we are doing when we are doing an index and when we are doing a similarity search. So normally when we if we are using an Elasticsearch or normal DB query that we do, right? So there what we do is it's an exact query, the exact search. We are searching by a word or we are searching by some data like ID or name, right? So these are exact values that we fetch here. But here, when we are doing a similarity search through vector search, right, through this vector indexing, here we are doing a similarity search. So it is basically searches through semantically it searches like which is the closest value. It will give me that, right? So this is the power of like semantic search, where we don't need the exact. We won't require the exact search, but only the similarity. So it will give. So it is useful when we are making some document searches, right? So where we want only the meaning should be the same and not the exact value, right? So this is where this comes in handy. So next, in the next class, what we will do is, so here we have in our other classes, we have built this movie recommender where we recommended from using our LLM model, we generated movies, right? So And then here we have also in the screener query, we had used indexing, which was stored in Pinecone. And then using that, we made our call and we got some response. So we will try to integrate all of them together, right? So maybe try like generating movies through a model and then storing it in a probability, or we will take it as a storing it in a local vector store. Then we will store it in a Pinecone, and we will play around with those things. So yeah, stay tuned. I'll be covering all those things. Okay, thank you.